October 11. This is Kwaai Day. What number Kwaai Day? Are we at 63? Fantastic. Okay, we've got a packed agenda. Myra, why don't you take us forward? But I see Diego waiting in the wings, ready to advise us, give us a progress update of the work group meeting, the AI for Life Sciences work group. Thank you so much.
Diego will be up shortly, but I don't know if you had any opening notes or.
Yeah. So look, it's October. We're coming up to another birthday for Kwaai. Today's October 11. On December 11 is the anniversary of when Kwaai was incorporated as a non-profit. We received our incorporation, our articles of incorporation, and we're actually a Virginia corporation, a 501c3 non-profit, and we're 2 months away from that birthday. So there are lots of birthdays to celebrate. As we run up to that birthday, we are going through the process of getting our new board elected and in place. So board elections will be running. We've got a good crop of nominees. We'll tell you more about that maybe next week. But just to let you know, we're in the sort of sausage making of preparing ballots and making sure that everyone is there's adequate transparency. And we formed an election committee, and they're going through making sure the elections run properly. So thank you so much, Myra, for presenting the agenda.
Yeah.
Tell us about Diego.
Diego.
Okay, I'll put you on the spot there.
No, but Diego, wow, the amount of research and work you've done is incredible. And I gotta say, you have been the hardest person for me to find pictures of, just because you have no social media. Along with all the research you've been doing, I'm very interested in knowing how and what your progress and accomplishments are with the AI for Med group, specifically in Kwaai. And then I have some questions about your other papers outside of Kwaai, but would love for you to start on that.
Hi, everyone. Sorry, what was the question again? Could you repeat it?
Oh, just go ahead with whatever you were going to present about your research at Kwaai.
Oh, yeah, perfect. So can I maybe share my screen?
Yes, I will stop.
Okay, thank you for preparing this slide. Okay.
Go ahead.
Where is my, I cannot see. Maybe I'll put it on my second screen.
Do we need to give Diego a co-host?
Sorry,
yeah, he's got it. This is the thing you deal with Zoom. You're projecting and it goes onto your second screen, and then you try to figure out where did my screen go? There it is.
Can you see now?
Yes.
We can see it.
Can you see full screen?
Yes.
Or okay, perfect.
Full screen.
Then now it's good. So for those that don't know me, I've been co-leading the AI for Life Sciences group within Kwaai. I really like the Kwaai mission, and I got, I think, into the early stage of Kwaai when Reza was starting this nonprofit, which I think is amazing. One of the things, okay, sorry, here also you can see Afshin is also, who is also in the call, is one of the co-leaders of the group, and also Kai Fan, which I haven't seen much in the last meetings, but probably he is busy also running his company. So, okay, so let me start. There are, of course, many questions that you can ask within these new technologies that were developed, LLMs, and how this is going to impact this life sciences field or area. And even within life sciences, there are so many sub areas or questions, again, that you can ask or that can be impacted by this. So we started with a simple research question in which we do have expertise, or at least I do have expertise, because I did work a lot before with building machine learning models for predicting side effects of medications. And the first or the initial question we had was how accurate are these off-the-shelf large language model are providing information or prediction about side effect of medications? And I think this question was also motivated by some doctors like Pinar that are on the group here. When they were mentioning that they use actually these advanced tools such as ChatGPT to ask questions about medications. Like, I think this is gonna become more and more standard in general for doctor practitioners who are out there again, trying to get some extra advice from this tool for making decisions. And what we want is to provide them with a good tool that can actually be useful for making informed decisions for patients, for the benefit of the patient, sorry. So this was the initial questions. We just wanted to test how good the system are off the shelf. We started with this data set that is called CIDR. I don't know if you are familiar with this, but there is a publicly available data set that contains all the side effects that are listed on the drug leaflet. So this paper, this piece of paper that you get with your medication or drug is called the drug leaflet. So they were extracted and mined from there, and this is what we use. And here below, you can see the two papers that I have published as a third author related to this field of drug side effect prediction. So this is just a diagram of how we wanted to ask this question to the LLM. So let's say for a given drug A, you have a bunch of side effects or a list of side effects. Then we want to design some query to ask, let's say ChatGPT as it is, whether this drug is known to be associated with this side effect or causes this side effect. And then we wanted to measure the accuracy, similar to a binary classification performance that you see in machine learning. And we tried this initially with ChatGPT 3.5 and ChatGPT 4, and we observed that the accuracy of this system, as they are, is very low. It was between 50% to 60%, and this improved a bit between the version 3.5 and 4, but still the performance is low. So this system, although they can give you information, they are not accurate. So this is what we showcase here. The same result we found with Llama. In this case, I tested it with Llama 2. And here you see, the reason why you see different bars here is because I tried with different temperatures, and it doesn't have basically any effect pretty much on the result. So it's not accurate. So that's how we came out with a solution that is based on, so we had two solutions actually that we have been developing. One is based on RAG or retrieval-augmented generation. And the way this works is that you have some data format. So this will be the drug side effects listed in a text format that you pass through this system of splitting this text into chunks. Then this is embedded into some space, in this case of 1500 dimensions, which is finally stored as numbers. So each of the pieces of text is going to be stored as a number in a database that is called usually a vector database. So what's going to happen now within this RAG system is that so let's say this is the end user here. If the user asks a question, is this side effect an adverse effect of this drug? Before we send this question directly to the language model, we are going to pass through this system here. So what this does is, first is going to embed this sentence or this prompt into the same space in which we have all the text that I mentioned before. Then we are going to query the database to find the most similar sentences to that, or the most similar vectors. And then we are going to return that, do some filtering, some prompt engineering, and at the end, we are going to provide the correct answer to the LLM so that the LLM can return the yes or no answer. So that is the idea. So the idea of RAG is to enhance the response by querying a database that we build specifically for this problem. So that's That's how I will frame it. Then there is a second platform that we build, a second pipeline or technology that is called GraphRAG. So this can be done because the drag side effect associations can actually be represented as a graph. So here you see a representation of that, which is we have a bunch of nodes that represent the drugs, a bunch of nodes that represent the side effects, and the link between them represent the known association. So there is a way also to load this information into a database. In this case, we use Neo4j. And then once you load all the drug side effect information here, we are going to have a pipeline within the user as well to retrieve the information from the database. So here is, again, the end user is going to ask a given question related to drug side effect. And this is going to go through this query to the graph database that is going to return if the node exists or not, if the link between the two nodes exists or not. So that's what the database is looking for. So let's say you ask, if aspirin causes headache, what's going to happen is this vector database, this graph database, sorry, is going to search whether the link between aspirin and headache exists in the database. And that what is going to return is going to return the actual link, or it's gonna return some empty value, right? Then of course we had to do some prompt engineering again to explain that to the language model, which at the end is gonna provide the final answer to the user. So these are two different ways to store the drug side effect information and to provide the correct answer to the user. One is based on RAG, in which we take the text, we embed it into some space, and then we store that into a vector database. And then the GraphRAG solution is we actually store the graph information into the database, and we just query the graph. There are two different ways to do that. So you may wonder how this works. So let me go through this plot. So this is the result. I know you are familiar with the violin plots, but inside you see also the box plot, but try to follow as I am explaining this. So here you see in the x-axis the accuracy. The ones that say LLM is just llama 3 without any drug side effect information. So we are here in around 50% accuracy. If you use RAG in a data format that we call data format A, this is the performance that you get, which is already around 90%, above 90%. If you use RAG with another data format that we try, because you can change the data formats, we get a much better performance, which is almost perfect. But the perfect performance here and the winner is definitely GraphRAG. So if you use GraphRAG, you are pretty much at 100% accuracy. So this is a perfect system pretty much that's never gonna make a mistake. And this result is actually consistent across drug classes because you may have more information for some group of drugs than for others, but the results seem to be consistent, which is good. Actually here, GraphRAG is the red bar, and you see that it's pretty much 100% for all the different drug classes. So these are categorizations of the drugs. And I want to give also a special acknowledgement to certain people that have helped during this project within the group, especially Shad. He also contributed some computational resources apart from giving his time in programming. So a lot of the solutions that I showed were actually also suggested and implemented by Shad. And then we have Pinar and Andre that joined also recently the subgroup. So and thank you so much for everyone else also attending regularly these meetings. And that's all I wanted to share. So we are writing the manuscript now on this.
Diego, thank you so much. That's fantastic. Amazing. It's going from LLMs, you said 50% accuracy. That's as accurate as flipping a coin. So ChatGPT on its own is as useful as flipping a coin when you're asking mission critical questions like this. And you've shown that by augmenting that with RAG, optimizing the RAG, and then applying GraphRAG on top of it, you can radically improve it. I think that's worthy of a paper. That's worthy of writing home about. That's great. Well done. So applause to you. Myra, you've got a question.
Yeah, RAG A and RAG B. What's the difference? Is that
So we,
the one with where the side effects and the drug names have graphical interfaces?
no, RAG A and RAG B are actually correspond to data for what we call data format A, and we have another data format that we call data format B, because we need to basically we needed to build sentences out of the drug side effect association in order to apply RAG, because the information you have from the database is only pairs of drug side effect associations, and there is no an unique way to build these sentences. So I think one way was we have the name of the drug and then we listed all the side effects, like this drug causes these side effects, and then we listed all the side effects together next to the drug. That is the data format A. The data format B is we have one line per each drug side effect. So we say aspirin causes headache. Then below we will have aspirin causes diarrhea. Then below and so on, right? So because we were trying different formats and how that will affect the performance, that's how we had these two data formats.
Okay.
That's very interesting. I think that's also a lesson for when we are instructing other people how to prepare their RAG database. Simply dragging and dropping a PDF into your repository might not be sufficient, because for a human, you might have, you know, a word you can process a long sentence and a paragraph, and you can also process two-dimensional tables and understand that. But RAG doesn't understand that. RAG is like passing a little window over all of the text. And if the sentence is not inside there, inside the chunk, if the information is not inside the chunk, then it doesn't see it. So this is a good case study.
Yeah, another thing that we feel, well, actually Shad figured out this, is that the text splitter is very important for the performance. So he wrote a custom text splitter to improve the performance, because we had even lower, I think we were at 10% less performance with RAG. And once this was fixed, actually, we managed to improve this and the dimensionality, these two things. So there are many things here that appears like off the shelf, but actually you need to understand the technology and you need to tune it to your data and to your problem.
Well, you were very lucky to have been partnered with Shad very early on. I know Shad was very active in all sorts of places, but looking for a place to contribute, and then he found you, and I think you've done some amazing work. So we got a number of questions. We got AZ's got his hand up, but let's see. Steve put a question in the. Steve says he's very interested in how specifically GraphRAG results are incorporated into improving the prompt itself. But is that where GraphRAG is applied, or you're applying it? Do the relationships become sentences that you add into the vector database, or is it done completely separately?
No, for GraphRAG is different, because you need to define the nodes and the links and the type of links. So in this case, the nodes can be drugs, can be side effects, which are these two here that you see, these two sets.
Yeah.
And then the links you need to define. In our case, it was, I think, like this may cause these side effects. So even the link needs to be defined in a certain type, right? So because generally in a graph you can have many type of links, many type of connections. If you think about knowledge graph, for instance, so this database allows you for that. So we needed to define that, and then when you basically here, I didn't explain this into too much detail, but when the user writes the query, we have this entity recognition module, which is also based on LLM, which what it does is it extracts this term, the name of the drug and the side effect, and uses that to query the database. So there are a lot of smart things here that were built in order for this to work. Because how otherwise you are gonna query this database if you don't know which drug and which side effect is referring to, right?
Right, indeed. So AZ's got his hand up, and then there are a few more questions in the chat as well. AZ?
Yes, thanks. I put my question in the chat as well. It's about the chunks that this text gets broken into. Are we talking about phrases or larger sets than phrases, but shorter than a sentence? Or are these chunks longer than sentences? I think that was the other slide.
At the end, the one that works best was breaking it into sentences.
Okay.
Yeah.
Awesome. Thank you. It's good to know.
And so it's not a fixed size of characters. You're actually looking for sentence boundaries.
No, it's not a fixed size. It's just end of the line, and then you break it, and then you use it as one chunk. So basically,
Fantastic.
what we are embedding is one sentence that say this drug causes this side effect, and that's one embedding.
So that's an important lesson for the Arcus Nexus team who've been struggling. They've had chunk sizes like 10,000 characters and wondering why it's not working, and haven't figured out how to optimize their chunking strategy. Okay. So a question from JB from Just Bry. How are you indexing and ingesting PDFs into your graph and vector databases?
So in this case, we are not actually using PDF because we are using this database of drug side effects. So this already gives you the pairs of the drug side effects. So it's a TXT file that contains all the possible pairs between drugs and side effects. So there is some pre-processing of this data set, which is what we use to build this data format A and B that I mentioned, and then also to build the graph. So yeah.
Right.
But we are not dealing directly with the PDF here.
Okay. And so
If I could ask a follow-up.
are there more questions?
Yeah, so when you're indexing that, are you delimiting it based upon just a new line or a period? As far as getting it into and you're using the same chunking for both the GraphRAG database and the vector database?
No, the GraphRAG doesn't require to chunk, only the RAG implementation, because you are doing the splitter before the embedding. So here, everything is based on new line for the chunks.
Cool.
Right. And the chats that are in the questions in the chat, feel free to vocalize them. Hank, do you want to ask your question?
Yeah, I'm just, first of all, thanks for this presentation. I have a big background in life sciences and pharma, and I was just curious about Freedom of Information Act data. Do you use that? Do you ingest that? If so, how do you go about cleaning it and making sure it's appropriate for use?
So you mean the data, the original data?
Yes. Yeah. Like, for example, you might say, hey, the FDA makes everything available to people about products and about adverse events and about indications and signal detection and things like that. And I want to have that be part of our use case. And so we would ingest FOIA data accordingly. But maybe you don't do that. Like maybe all your data is from some other sources.
So for this project, we are using the CIDR 4.1 database. So in this database, they already collected this, or they extract the side effect directly from the leaflet of the drug. So they are as reliable as it gets in terms of drug side effect information, because they are written in the drug leaflet, right? But I know they include the data from clinical trials also not only performed in the US, but also in Europe, because you have different regulatory agencies also in Europe and in Japan. So here there is a mix of everything.
Got it. Just one quick follow-up. And maybe we can't do this here, but I would be interested in knowing how you deal with concomitant medications, right? Like, sure, the leaflet says this caused a headache or myocardial infarction, but only when you combine it with this other drug is it really deadly. And so unless you know what the other drugs are, right, how do you know that you have a proper signal? Okay, yeah.
Yeah, but for that's a different problem, right? Because that's drug combination or drug interaction. For that, so now that we have developed this technology, we can apply it to pretty much any database. So I think what you're mentioning is a very important problem as well, and that can be solved already with this technology. Actually, this can be generalized, this GraphRAG solution, and we were discussing this in the subgroup. This can be generalized to pretty much any problem in which you have relations, or relational information is usually called. So when you relate something to another things, And this is an accurate way to feed that into an LLM and provide the answer to the user.
Diego, fascinating. Thank you so much. Thank you for answering my questions.
And Diego, the Arcus team are on, Roy and Annie and so on. So offline, they'll probably want to reach out to you and get advice as they're thinking about how to optimize their chunking strategy. Okay. And I was also going to ask about those drug interactions. Let me ask a different question. So imagine this is in production now, and every doctor's office has this, and it allows them to they would actually have these have this chatbot, but provide the ability for their patients to query the chatbot themselves, so that it provides kind of a 24/7 customer support service. They don't have to call up the doctor. And so it's out of hours. Hey, I'm feeling blurred. I'm suffering blurred vision. Maybe they can talk to the chatbot. Is that a side effect of the recent prescription I was given? How would that work? Tell me your thoughts around that.
I think with this system, we will have to make certain modifications for that, but I think it can be done, especially because here we were doing an assessment. So we were trying to measure accuracy. I had to restrict, or we had to constrain the answer of the LLM to be yes or no. So that's one of the constraints we introduced. So if you remove that constraint, this system is going to answer similarly to any LLM. Like when you write a question to ChatGPT, it's going to give you more context, more information. And also that information can be also probably stored in the database as to provide more data to the LLM in case it doesn't have. Because one of the things we discovered, but I didn't present it here, is that we realized that because these large models were trained with just a lot of data from the internet, a piece of that is based on pharmacology or information about the drugs, but it doesn't contain all the drugs, only a subset of them. So let's say for aspirin, it can be very accurate. It can give you a lot of information, but for some rare drug, it doesn't have any information. So it will just say nonsense, right? So I think there is a stretch to building that, but we have already the technology, right? It can be done, I think, from this.
Well, it's also important for the AI to say, I don't know, when it doesn't have the information. So Zach's hand went up, and then John Connors. So let's have Zach first.
Okay, thanks for that presentation, Diego. Just a real quick question. I'm sure that there is a lot of depth to the graph database that's not being represented in the visual. But what are your plans for evolving that, further categories, ontologies, semantics, relationships? Like, how do you see that growing in the future?
I think one way could be building a knowledge graph, right? Which is what you are mentioning, integrating all these databases that we have available. Now that we know how to build an accurate system like this one, I think this can be very easily generalized. The reason why we kept this small within this problem is because also because it's expensive to do this assessment. I don't know, like there was money spent here. Actually, Chad put some money from his company donated to doing this experiment. But it can be done, I think, and especially I think we have also discussion with Afshin that this can be a very useful tool also for biologists, bench biologists working on labs, and not only doctors, but also people working in biology or computational biology.
Right. John, you've got a question?
Yeah, just quickly, the great presentation and great questions that led to realization. How could this be applied to personal AI? And if you think about it for a little bit, just to plug, we've got a Summit 25 hackathon coming up in February, late February, early March of 25. So as your LLM develops and this cross-relational database comes up, is there a way that's HIPAA compliant for a individual to have access to their entire suite of medications and how they'd impact themselves in a way that wouldn't share with LLMs that would and eventually lead to data corruption, is there the possibility where we could get some people to build out a Pi app, a Kwaai, focused app at one of these hackathons?
I think that's more a question for Reza, but
Their YouTube open up.
I think it's a bit of a different problem working with because that requires access to electronic health record, right? So even the formal electronic health record needs to be processed and
Or
somehow
data
stored.
or data input from the medical user side. They could
Yeah.
they could type in a box of what medications they're taking.
Yeah, I mean, if they are only doing that, that can be done already as it is, as the system is built. But if you want to have access, personalized access of the patient in time, I think we need to have like another database only of the patient where that is stored and the system can access to that. Of course, there should be some security measures such as login and all that you guys probably know better than me, but I think it can be done, right? So the part that is
technically it can be done.
Yep.
Yes, the privacy and security is a problem. Just a question around the drugs have generic names, and then they also have their sort of branding name. So ibuprofen is a generic name, but you've got Aleve and you've got all sorts of, Indocid, indomethacin. There's all sorts of sort of anti-inflammatory drugs that are in a class. Is that the job of the graph database to represent that class of drugs?
So far that is no we did not handle that problem here, because you can have many synonyms for name of drugs and also for side effect terms, because the term we use are called MIDRA terms, which are usually medical terms for the side effect, but people may not know them. Like most of the I wouldn't know most of them, right? So I think that is definitely one of the problems that need to be addressed for this to reach like patient level use case. But I think there are some libraries to do that. So some databases that can be mined to incorporate that into the graph database. Especially, I think this entity recognition module is the one that it needs to expand to query another database here to find all the synonyms before doing the graph query.
Cool. Okay, we got some comments in the chat we can pick up on later on, but Diego, thank you so much. This is so informative, and it's great to see progress. I know your meeting. If anyone wants to participate, Diego runs a bi-weekly work group meeting. Go find it on the Kwaai calendar, and see if you want to participate. See if you just want to observe. Thank you so much, Diego. That was fantastic. Myra, why don't you get us back on schedule?
Thank you, everyone.
Yeah, thank you, Diego. That was very enlightening. We have work group updates next. So I don't know if you've updated these, Reza.
I think what we'll do is we'll have Sam. Sam probably was going to want to give us an update on the open source definition and what's going on.
Yes,
We'll on that shortly. Sorry, go on, Myra.
No, I was saying I was following all your posts about that. So yeah, please go ahead.
Yes. Okay. Well, it's no doubt difficult to follow, but even more difficult to write. So look, the open source AI definition continues its slow and largely pointless march towards the 28th of October launch of the 1.0 at the All Things Open conference. My very recent realization, I was up quite late last night. The town hall, the 20th town hall on the topic was at midnight. And so I did that call and then spent the next 2 or 3 hours documenting it and publishing a post on it, which is on my on LinkedIn for those following me like Myra, and also on samjohnston.org. You'll see the last half dozen posts about that, but also on discuss.opensource.org, where the last couple of dozen threads are on the availability of data. And that's the issue. The point is the data is essentially the source code. It's the thing that developers, AI practitioners go to when they want to modify how a model actually works. And it's been quite simple in open source because if you had a piece of source code and it was licensed under an OSI approved license like GPL or MIT like us or Apache 2 or whatever, which is to say that it fully protects the freedom, the four essential freedoms to use, study, modify, and share software. So if you have this source code, which is OSI approved license, and it produces the software, then you're good. It's done, right? And you can release it, and nobody needs to check your homework or whatever. And if you lie about it, then somebody, we can raise exceptions. But with AI, it's kind of, they're arguing that, well, the source code there's no source code, so we don't need to have source code, and they're kind of moving away from this idea that you need to protect the four freedoms, even though the four freedoms are explicitly listed in the release candidate document. I believe, and even last night, I really tried to drive them to say, yeah, we believe this document protects the four freedoms, and we still aspire to do that, right? Because we are the open source initiative, and the industry understands that's what open source means. And I feel like they've kind of tried to solve this impossible problem of finding like a consensus, a DEI approved kind of consensus, which may be an impossible thing to do, and it certainly isn't what we understand open source to be. So the definition out there is the result of this co-design process, and it's a definition for something, but I don't really know what it is, right? So that's where we're at. If I had one ask for one request for you, it's to track me down on LinkedIn and repost. I saw that a couple of people have just done that, so that's good. Form your own opinion. I don't need or expect you to necessarily agree with mine. I've a bit had to be kind of the noisy bad cop here and really kind of lay out the issues and try to dress them up so that people kind of pay attention to them. But I don't need you to necessarily follow that. But it is something that I think will miss a huge opportunity here to create a strong incentive for people to create open data sets like the AlphaFold data set, which won the Nobel Prize yesterday, and it is Creative Commons licensed, right? So this decision was clearly made in a kind of smoky back room, like late last year. It was seeded into the first half of the first town hall, and the OSI has not moved 1 millimeter on it, since then. And so, it creates the space, the commons on which you build things like the personal artificial intelligence operating system. And if everybody can, call their thing open source, then nobody's open source. The term is meaningless. And not just in the context of AI, like in open source in general, right? And a former board member has just come out and said that they don't even believe that the OSI has the mandate of the membership, as evidenced by that question being asked in a consultation late last year, and less than half the people put up their hands and said, we actually need to answer this question. So, they're kind of answering a question nobody's asked them to answer. They're giving the wrong answer because they've kind of conducted this experimental, inclusive process, but they're now really shifting what it means to be open source. Very quickly, the update on the development is that we are we're focusing on where we are on the critical path for the launch of the beta. So Robert and Sanu, for example, have been working on passkeys. I've now incorporated the passkeys. I'm now working on email authentication, so you can't just go in and say that you're samj@samj.net without sending an email and clicking on a link. So I'm doing that, and that is its own can of worms. If anybody who's ever sent an email as a sysadmin or whatever understands now with SPF and DKIM and DMARC and all the rest of it. So we came up with a good solution to that yesterday. I'm going to implement that. Robert and Sanu are going to integrate that on Monday. We're probably going to work together on that. And then that's going to get us off the critical path so that Roy and co can continue to integrate the work we're doing. So I've taken a few more minutes than the couple that I was allocated, but hopefully that update is useful.
Yeah, look, I thought maybe we could hear from a few more voices on the OS, some of the other contributors. Patricia, I know I hate to put you on the spot, but maybe let's hear from you. And you've got some other contributors, obviously Robert Bidding, but I don't think Robert's on the call. But Patricia, you're on the call. Let's hear from you.
Thanks for putting me on the spot, Reza. I
Thanks, I'm
have
going to
been
spotlight
working.
you.
Yes, thank you. I have been working on integrating Light LLM into PyOS, with the goal of not hard coding any dependency on a particular, a particular model or a particular provider. So that is what I am focused on at the moment.
Great, thank you so much, Patricia. Myra, why don't you get us onto the next slot? Who's up next?
Yep. Also, I put your LinkedIn profile link, Sam. So if anyone wants to follow up, read all your articles, please. Look at yeah.
We skipped over the Pi Assistant update. Let's get a Pi Assistant update. If Balaji is on the call, I know that Cyan's not on the call because he's at Oktoberfest.
Nice.
So, and I don't see, Balaji is on the call. Balaji, why don't you give us an update, and then maybe Roy and Annie, if you are there as well.
Yeah, sure. Hey, so this week the work group met. We discussed a few things about deployment and DevOps related tasks that we need to perform, and there was a separate meeting that happened to particularly address these issues. I think there's two sides of this beta deployment. One is getting the we talked about getting the authentication, the passkey, and other aspects drawn into the prototype that we have, so it can complete that part. And then the next part is to deploy it in a fashion that it is going to be conducive for the educational universities to take that and put it in their own network. That's a very high level as to what's going on in the work group. And for details, if Arcus Nexus is there, they should be able to.
I don't know who from Arcus Nexus.
Hello, I'm here.
Hello,
Roy.
Roy. Hey, how you doing? Okay, there we go. Let's get Roy's spotlight.
Okay, well, for this week, we continue working in the integration of some features that was development in the development branch for Patricia, the chair, for Robert, the users. So we are working on integrate this on our branch. So far, so good. We are planning to have for the next week a demo with the users integrated. So when we have user, we are going to be available to blow up in a server for the demo.
Right. Okay. So we're always at this stage in any software development where the engineers say, well, it's working on my laptop, and the guy who's running the data center or the production environment says, well, yeah, that's great, but how does it get into onto the hardware and deployed? And so we had a first meeting of a DevOps sort of task force to help automate what in software engineering is called continuous integration, continuous development, CI/CD. And that's the automation of the deployment scripts so that you can have a repeatable process. So when the software engineer builds the code, it can get deployed to either the development, the QA, or the production environment. So these are the sort of basic foundation, motherhood and apple pie type of things that most software engineering projects have. Sorry, we didn't put this in place in the beginning, but we're getting it there. And we got probably the world expert on this. We got Darren Warner, and I've worked with Darren Warner for a long time. We got him involved, and he came and sort of gave us a one-on-one, a 101 DevOps lesson on Tuesday. Hopefully he's going to participate in that automation. We've also got a really skillful software and hardware engineer, Jeff Kramer, who runs the data center in Sacramento for iBridge. They're going to be hosting the beta. And they're a partner of ours. They're hosting it for free. They're donating their data center, their GPU data center to Kwaai to host the beta. And now we just need to get it from those builds. We need to get that process automated. So we're working on that. That's probably the biggest hurdle for us, getting it to a point where everyone within Kwaai can kick the tires on the latest chatbot platform. The great innovation that Sam's team has done is the multi-tenancy. As I said before, running a chatbot in AWS is a $2,000 a month cost. And that's for one chatbot. So running it in the PyOS, running it on the PyOS in the iBridge data center, you can have 1,000 chatbots on the same server. So it's 1,000 to 1 cost reduction. So that's a fantastic step forward in the mission to democratize AI. So well done. And then what Roy's team has done is taken the proof of concept user interface, the one that you see on the website, and has brought that up and made that into a more professional, more up-to-date user experience, where you not only experience the chatbot from the end user point of view, but also from the bot owner's point of view, where you can curate your data, you can construct the persona of your chatbot, and you can curate the data a lot more easily. So all of that to come. It's very hand wavy at the moment, but yeah, that's where we are. AZ, you do have your hand raised.
Thank you. Thank you. I've put this in the chat as well. Seconding what Moira said, Sam has updates on LinkedIn. Reza has updates on LinkedIn. Reza reposts what Sam does, and I often repost what I see that's important. All of us need to do that. Every single one of us is an ambassador. We should be doing volunteer outreach. We should be bringing people in our networks. We should be telling them what an amazing group this is, how we're making history, we're doing important things. Each of us is an ambassador, and I think this is a message that we may want to repeat at least once a month, more often. We are ambassadors. We have to do more outreach. We have to do more interactions, connect on LinkedIn with Reza, with Sam. And when you see this stuff happening, when you see these chats happening, repost them, raise the noise. So that's what I wanted to say. It's in the chat. Thank you so much.
Fantastic.
Raise the roof.
Exactly.
Raise the roof. Okay. I'm going to quickly share a screen just by way of giving you an update on funding. And here is my screen share, and it's a snapshot of where we are with in-kind funding. Before I published this graph, and it went up to May, and we've got a brilliant spreadsheet modeler, a business analyst. Her name's Ankita, and she's not on the call at the moment. She's on vacation, but she took what I'd done up until May, and she said, well, I'd rather than just modeling out the numbers based on the membership, I want to model it based on the actual work that's being done. So she took the analytics out of Slack. Slack counts all the messages per channel, per work group, per individual, and she came up with this analysis of the in-kind contribution that you guys have made to the movement, to Kwaai, and placed a value on it. And this is fantastic. This shows what a movement can do in terms of if you're thinking about the monetary value of your work, of your effort, and your tired hours, your time between jobs, and the passion that you have for democratizing AI. So thank you all very much. Thank yourselves for creating value. This is real value. This is the sort of graph I said, okay, well, we're applying for grants, and the grant owners want to know, what is your traction so far? What have you achieved so far? And yeah, okay, well, we're holding a lot of work group meetings. Now this graph actually consolidates that, translates that into dollars and cents. and is very meaningful, and saying, hey, you know, this is what we've achieved on passion alone. Imagine what we could do if you were to award us one of these grants that we're applying for. So that's what's going on on the grant and the funding activity. I'm going to stop sharing there. Over to you, Myra. Let's hear from.
Should we do some member voices? We only have 7 minutes, but let's look through our list. Who do we have?
And you know I'm going to call on you if you don't put your hand up. So
No.
Debbie, you had breakfast with Ted this morning. Tell us about that.
I did. It was such an honor to meet Ted, and it was a lot of fun, actually. He is a very interesting person. He's had a lot of interesting stories because he's lived a very interesting life.
But hold on, you're right in the middle of a hurricane and you're having breakfast with him.
No, the hurricane passed. Actually, today's raining more down here in South Florida than it did during the hurricane, because that's life. But he is actually down here because his girl, they had to evacuate. They were in Bradenton, which is the area that got hit really hard from Milton, the hurricane. So we connected at the Waffle House. Or
in real life, at a Waffle
in real
House.
life, yes. So it was a lot of fun to eating waffles and pancakes also in the picture with Ted Cohen. And you realize that there's so many people in this world that have had all these experiences. And he basically, think of every band that you know, from, you know, the Cranberries to Aerosmith to Van Halen. I mean, just anybody. And he's either worked with them, he's advised. I mean, he was there like with them.
Fantastic.
And actually his role with tech and music and AI is really interesting. And he's someone who has tremendous value. So yeah, really appreciated my breakfast with Ted.
Well, he was a consigliere on one of the startups where I was CTO, and he did a really good job for us. I'd like to hear from, and I see you're in the car, Ira, and I'd like to hear from you, even though you're in the car. Are you safe to drive? Are you safe to talk?
Yeah, I am. I'm just getting off the highway right now. And the only reason I'm as late as I am, my apologies, is that we were at a high school tour. LA is a place where getting your kid into high school is as challenging as getting them into college. But I wanted to say a couple of things. One of them is that Reza, when we get a chance offline, I want to share with you someone who I think might be a really ideal person to know. She's in the world of edge computing, and I got a sense, and I shared it with Lynn as well, my wife. For anybody that doesn't know, Lynn is also a member of this group, and I didn't catch the name of the person within the group that suggested ambassadorship, but as a lifelong business development executive for several companies, I have often found it to be the biggest strength of any community is its ability to teach business development to all of its members, because everybody, as an ambassador within a community or within an organization, is in a capacity to actually extend the mission and evangelize. And I treat it very much like evangelizing. So I would be more than happy to extend that conversation. I can't recall who it was that spoke up about it, but let's, if you don't mind, get together and talk about whether or not there's some things we can do to help raise the bar of the emotional intelligence cues and raise the bar of how we actually reach out to people in very respectful and desirable ways. And maybe we can add that as an element to this group here.
Well, Ira, thank you so much. And I'm looking forward to seeing you tomorrow.
Indeed.
Thank you for inviting us to come and dine with you. Thank you.
It's utterly our pleasure. It's been way too long, Reza, because while showering today, no images needed there in our minds, but while showering today, it occurred to me, I just can't believe that it's been 20 years. It's been 20 years since I've met you, and that's just so surprising to me.
It's crazy. Okay.
It really is. Thank you.
Well, let's see. So Jim Chappell, you've got your hand up.
Well, hello, everyone. So I have been lurking. I'm up to episode 41 from one of all of the events. And once Doc Searles started to post about Kwaai, I decided I had to take a look. My first IIW exposure was in 2012. I'm a Silicon Valley. I was born in San Jose, and was there until 2020 and have 40 plus years of infrastructure technology experience. My first job was working on something called MS-DOS. And so I figure PyOS, MS-DOS, PyOS, that's a great kind of spectrum, storage, networking, identity. And so when I saw that the beta was going to be available to Kwaai members, I said, well, okay, I'm not going to watch the rest. I'm not going to go all through the videos. I'm just going to jump in the tank. And so here I am.
Let's fast forward. Look, Jim, we'd love your contribution at the coding end as well. My
experience is I have a degree in computer science, but I've never coded for my living. Just like the business development discussion, I have always been on the most engineers figure if you build it, they'll come. But there has to be a go-to-market side of every equation. So I'm the go-to-market side with a little computer background.
Well, I think we could use your help there as well. Fantastic, Jim. Thanks so much, and I hope to see you at IIW end of the month if you're going to be there. Great. So on that note, look, we're a minute away. There's an after party straight after this. If have you posted the link yet, Myra? That would be great. And that's where we dive deep into one or two of the topics that were covered in the Kwaai Day call. But if I don't talk to you again, have a fantastic weekend and look forward to seeing you all next week.
Yep.
Great.
Please check out the link in the chat. Thanks, everyone.
Ira,
Thanks,
I sent
everybody.
you a connect request with a message. We'll connect with you. Thank you so much. Take care. Ira, I sent you a message. Yeah, on LinkedIn. Thank you. Take care.
Great.
Bye all.
Thank you.
See you.
Bye-bye.
Take care all. Bye. Thank you.